Hey everybody, Mark with Mastering It with Mark here. I'm going to show you a couple things about a circle that I've been looking at lately in some tutoring sessions, both with standardized tests like ACT and SAT, and also with people's math homework. So if we have a circle on the XY plane, the standard XY plane, the equation, we like to say the equation for that circle is x squared plus y squared equals radius squared, r squared. So, but here's how that works. Here's why that works. So if I pick, let's say, any point along the circle, I'm going to pick a point where the x and the y values are both positive. And if we look at this and we say, okay, to get to this point, right, from the center, which on this one happens to be the origin, but more importantly, from the center of the circle, I go this direction, positive direction, along the x-axis, and then I go up this direction along the y-axis to get to that point. Well, what I did here was make out of those two legs and the radius of the circle. Remember, the radius of the circle is any line that goes from the center of the circle to any point along the edge of the circle. So using the radius and the counting over here on the x-axis and the counting up along the y-axis to get to that point, we've made a right triangle. Simple as that. Remember, I'm going to go to another page here. Remember, on a right triangle, you can find any of the sides if you have the other two sides using Pythagorean Theorem, which goes a squared plus b squared equals c squared, where c is the hypotenuse, or in other words, the longest side of the triangle. So if I have a and b, I can just type that in. I can plug those into that equation and get c. If I have c, I can plug it in and get the other. Whatever you're missing, you can plug in the two that you know and get the other one. So same idea goes back to this. That's how this equation works. That's how that formula works, I guess. So you could theoretically, solve it for y or solve it for x. You could say y is equal to the square root of r squared minus x squared. Same idea. Or you could say r equals the square root of x squared plus y squared, right? Just take the square root of both sides. But either way, it all boils down to, this is the Pythagorean Theorem, because from the center of the circle to any edge point, you go a certain distance along the x-axis and a certain distance along the y-axis, and you connect. Obviously, the middle of the circle always connects with the edge of the circle with a radius. So no matter where you are in the circle, so even if you go over here, let's do a different color here. Let's say green. So if you go over here, well, actually, let me do this. Go over here. You go a certain amount along the x-axis and down along the y-axis, right? And from this point, still the radius connects those 2 points, the middle of the circle, the center of the circle, and the point along the edge. So you've got a right triangle here. And you've got, in this case, x is negative and y is also negative. So, well, what would happen if you had negative x? Well, you're still going to square it. Negative y, you're still going to square it. When you square that, it becomes x squared plus y squared equals r squared. Same thing. Now, this is handy when the center of the circle is at the origin, 0, 0, right? What happens when the center of the circle is not at the origin? So let's look at this one. Here, my center is in quadrant 1 here. right? Both x and y of the center are positive, not 0. My origin is over here. My center of the circle is here. It's the same size circle. So my radius is, let's say, I'm going to draw a radius like that. My radius is the same. Nothing changed about my radius. I just shifted the circle to a different spot on my XY plane. Now, think about this. From the center, you go over this amount, right, on your along your x-axis, and you go up this amount on your y-axis. But this point, this xy point, right, this coordinate point here, you have to account for the fact that we're not at the origin anymore. This amount of travel, I guess, along the x-axis has to be deducted from this point here, whatever number this is here. We have to deduct this amount because we're only talking about this amount for the equation purposes. So in our x squared plus y squared equals r squared, what we're going to do is, what we have to do anyway, we have to say, okay, well, if I'm going to pick any point, but for my x value, I'm going to use this x value, which is this number minus this number, right? Minus that number. That, we'll call that h comma k. We'll call the center of the circle is kind of like the vertex of a parabola, where we call it h comma k in the coordinate points. So for my x value here that I put into my Pythagorean theorem, I've got to take the x value here, but I've got to subtract this part that we're not using, the h value, because we went over to h, and here we go up to k. So I've got to subtract that h value from my x value here before squaring it. Likewise, for my y value, well, for my y value, I'm counting up, right? Up to here. That's my y value, because that's in my little triangle I make, that's this leg. So that y value, this number here, though, is not the same as what I can put into my equation, because it's not from the origin, it's from the center. And so I've got to deduct this part from my y value before putting it in my equation and squaring it. So I say y minus k, and then squared. Hope that makes sense. Now, the radius, like I said, I didn't change the size of the circle at all. I just shifted it to a different part of the coordinate plane. So I still have radius squared. So that way, that's why this is the actual equation of a circle on the xy plane, where h and k, not negative h and negative k, but h itself and k itself is my center of my circle. So if my center of the circle is, let's say the center is, just theoretically, if the center is 3 and 4, 3 comma 4, right? So if my hk is 3 comma 4, right? And let's say my radius is 5 units. Just theoretically, let's say my radius is 5 units. So my equation of that circle would be x minus the x value of my center, which is 3 squared, plus y minus the y value of my center, which is 4 in this case, squared, equals r squared. Well, if I'm saying my radius is 5, then it'd be 5 squared, which is 25. So if my center is at positive 3, positive 4, this is my equation of that circle. The same is true no matter where the circle is. Even if we move the circle to a different quadrant where where either the x value or the y value of the center is negative, it's still x minus h. So if h is negative, then whenever you put that negative number in here, the negative and the minus sign will cancel out and it'll be plus. So like for instance, if my circle was over here and it was -3 for my center over there, then it'll be x minus -3, which is x plus 3. See how that works? Whatever you see, the opposite of whatever you see inside there, the opposite of that, that's where your center of your circle is. So if I see an equation like this, and I say, well, if my equation is x minus 5 squared plus y plus 7 squared equals 36, right? Well, that tells me that the center of the circle is +5, because it's the opposite of what I see in here, because you're subtracting that from the x, +5, and negative, which is the negative of what I see here, the opposite of what I see here, -7. That would be the center. And the radius would be, well, the square root of that, because remember it's r squared in your equation. So the radius would be 6 in that case on that one. Hope that all makes sense. Let me know if not, and I can explain it further, or we can get together and we can talk about it some more. Thank you.